The directions say to solve each exponential equation. Let's take a look at example 1. Suppose 2 times 2 to the 2x minus 3 times 2 to the x plus 1 equals 0. What we're going to do is we're going to let u equal 2 to the x. If we square both sides, we get u squared equals 2 to the x quantity squared, which is equal to 2 to the 2x. So I want to now rewrite this equation in terms of u and solve for u. And when we do that, we get 2u squared minus 3u plus 1 equals 0. Factoring the expression on the left-hand side, we get 2u minus 1 times u minus 1, and we're going to set that equal to 0. And our goal, again, is to solve for u. And to do that, we're going to set 2u minus 1 equal to 0 or u minus 1 equal to 0. And so if 2u minus 1 equals 0, we can say u equals 1/2. If u minus 1 equals 0, we can say u equals 1. But remember that u is equal to 2 to the x. And so that says 2 to the x equals 1/2 or 2 to the x equals 1. Solving for x, we get x equals -1 or x equals 0. And so the answer to example 1 is the set containing -1 and 0. Let's take a look at example 2. Suppose we are given 4 to the x minus 9 times 2 to the x plus 8 equals 0. We're going to solve this just like example 1. So what we're going to do is we're going to let u equal 2 to the x. Square both sides and we get u squared equals 2 to the x quantity squared, which is equal to 2 to the 2x, which can be written as 2 squared raised to the x power. But remember that 2 squared equals 4, which says u squared is equal to 4 to the x. So now we can rewrite this equation in terms of u. And when we do that, we get u squared minus 9u plus 8 equals 0. So u minus 1 times u minus 8 equals 0. And remember, we want to solve for u. So it follows that u minus 1 equals 0 or u minus 8 equals 0. So u equals 1 or u equals 8. But remember, u equals 2 to the x. So 2 to the x equals 1 or 2 to the x equals 8. Now don't forget, 8 equals 2 cubed. And remember, our goal is to solve for x. So what we have is 2 to the x equals 1 or 2 to the x equals 2 to the third. So x equals 0 or x equals 3. So the answer to example 2 is the set containing 0 and 3. Let's take a look at example 3. We have 5 to the 2x squared minus 4 minus 20 times 5 to the x squared minus 2 plus 75 is equal to 0. So I'm going to factor out a 2 from 2x squared minus 4. And when I do that, I get 5 to the 2 times x squared minus 2 minus 20 times 5 to the x squared minus 2 plus 75 equals 0. But we can write this as 5 to the x squared minus 2 raised to the second minus 20 times 5 to the x squared minus 2 plus 75 equals 0. Let u equal 5 to the x squared minus 2. So u squared minus 20u plus 75 is equal to 0. So we can say u minus 5 times u minus 15 is equal to 0. Remember, our goal is to solve for u first. So we're going to set u minus 5 equal to 0 or u minus 15 equal to 0. So that says u is equal to 5 or u equals 15. But don't forget, u equals 5 to the x squared minus 2. So 5 to the x squared minus 2 is equal to 5 to the first. Or 5 to the x squared minus 2 is equal to 15. Which says x squared minus 2 equals 1. Or x squared minus 2 equals log base 5 of 15. So remember, I can't rewrite 15 with a base 5 nicely, which is why I'm using logarithmic notation to solve for x with this equation here. So if x squared minus 2 equals 1, we can write x squared equals 3. I just add 2 to both sides. Solving for x, we get x equals plus or minus the square root of 3. Now, if x squared minus 2 equals log base 5 of 15, I'm going to add 2 to both sides and say x squared equals 2 plus log base 5 of 15. Solving for x, we get x equals plus or minus the square root of 2 plus log base 5 of 15. And so the answer to example 3 is the set containing negative root 3, positive root 3, negative the square root of 2 plus log base 5 of 15, and square root of 2 plus log base 5 of 15. Let's take a look at example 4. And you notice the difficulty level increases as we're going through these examples. So in example 4, we have 64 to the 1 over x minus 2 to the 3 plus 3 over x plus 12 equals 0. Now remember, 64 is 8 squared. So on the next line, I'm going to write 8 squared to the 1 over x minus 2 to the third times 2 to the 3 over x plus 12 equals 0. Which says 8 to the 1 over x raised to the second minus 8 times 2 to the third to the 1 over x. So there's a lot of laws of exponents going on here. Plus 12 equals 0. So let me say that again. It's 8 to the 1 over x raised to the second minus 8 times 2 to the third raised to the 1 over x. Because remember, 3 over x can be written as 3 times 1 over x. And a to the m raised to the n is equal to a to the m times n. So this is what's going on from here to here. So 8 to the 1 over x raised to the second minus 8 times 2 to the third to the 1 over x plus 12 equals 0. So 8 to the 1 over x raised to the second minus 8 times 8 to the 1 over x plus 12 equals 0. So it took a minute to set up this for my u substitution. And my u substitution will be as follows. U is equal to 8 to the 1 over x. So we can now say u squared minus 8u plus 12 equals 0. So u minus 2 times u minus 6 equals 0. So u minus 2 equals 0, or u minus 6 equals 0. So u equals 2, or u equals 6. But remember that u is equal to 8 to the 1 over x. So 8 to the 1 over x is equal to 2, or 8 to the 1 over x is equal to 6. Now, in the first equation, I can rewrite both sides with base 2. And it's much harder to rewrite the second equation to have a base 2. So in this, or any base, any common base for that matter. And so in the second equation, I'm going to use logarithmic notation to solve for x. Now, if 8 to the 1 over x equals 2, then 2 to the third to the 1 over x equals 2. So 2 to the 3 over x equals 2 to the first. So 3 over x is equal to 1, right? Which says x equals 3, right here. And if 2 to the third to the 1 over x equals 6, we can say 2 to the 3 over x equals 6. And I'm going to take the natural log of both sides. So natural log of 2 to the 3 over x is equal to natural log of 6, right? So 3 over x times natural log of 2, so I'm bringing this exponent out in front of the log. So 3 over x natural log of 2 is equal to natural log of 6. Dividing both sides by natural log of 2, I can say 3 over x equals natural log of 6 over natural log of 2. Now what we do is take the reciprocal of both sides. So x over 3 is equal to natural log of 2 over natural log of 6. And then multiplying both sides by 3, we can say x equals 3 natural log of 2 over natural log of 6. So x equals 3, or x equals 3 natural log of 2 over natural log of 6. So the answer to this example is the set containing 3 and 3 natural log of 2 over natural log of 6. That's example 4. So let's take a look at example 5. Suppose 5 to the x plus 1 plus 5 to the x plus 5 to the x minus 1 is equal to 155. I know that 155 seems kind of weird, but you'll see that it works out really nicely. So on the next line, again, using our laws of exponents, we can say 5 to the x times 5 plus 5 to the x plus 5 to the x times 5 to the negative 1 is equal to 155. Now, don't forget, 5 to the x is equal to 5 to the x times 1. And so notice how I have a 5 to the x common to all three terms. So I'm going to factor that out. And when I do, I get 5 to the x times the quantity, 5 plus 1 plus 1/5, right? Because remember, 5 to the negative 1 equals 1/5. And then on the other side, I get 155. But 5 plus 1 is 6. So 5 to the x times the quantity 6 plus 1/5 is equal to 155. But 6 plus 1/5 is 31 over 5. So 5 to the x times 31 over 5 is equal to 155. Okay. And then from here, I'm going to multiply both sides by 5 over 31. So that's essentially what I'm going to do first. So on the left-hand side, I'm going to multiply by 5 over 31. And on the right-hand side, I'm going to multiply by 5 over 31. Okay? And then what happens is I get 5 to the x is equal to 155 times 5 over 31. It turns out 31 times 5 is 155. Okay? So 31 goes into 155 5 times. 5 times 5 is 25. So what we get is 5 to the x equals 25. Solving for x, we get x equal 2. And so the answer to example 5 is the set containing 2. Now, we won't do the whole problem for example 6, but I want to show you how to attack a problem like this. Suppose I had 4 plus square root of 15 to the x plus 4 minus square root of 15 to the x. And this is equal to 62. This problem looks a lot worse than it is. Okay? Here's what we want to observe. Four plus square root of 15 and 4 minus square root of 15 are conjugates. Okay? Now, the way this is going to work is I'm going to multiply both sides of the equation by 4 plus square root of 15 raised to the x power. So I'm going to take 4 plus square root of 15 to the x times 4 plus square root of 15 to the x plus 4 plus square root of 15 to the x times 4 minus square root of 15 to the x. And I'm going to set that equal to 62 times 4 plus square root of 15 to the x. It's really slick. Now, from here, I want you to note something. 4 plus square root of 15 times 4 minus square root of 15 is equal to 16, that's 4 times 4, minus 15. So square root of 15 times square root of 15 is 15. So you get 16 minus 15, which is equal to 1. And so 4 plus square root of 15 to the x times 4 minus square root of 15 to the x is equal to 1 as well, I claim. Okay? Now, watch what happens here. We get 4 plus square root of 15 to the x raised to the second power. Okay? That's the first term. Plus 1. And we're going to set that equal to 62 times 4 plus square root of 15 to the x. And this can be done by use substitution. So I'm going to let u equal 4 plus square root of 15 to the x. And when I make my substitution, I get u squared plus 1 equals 62 times u. So u squared minus 62u plus 1 equals 0. And then what you want to do is solve for u, but to solve for u, you want to apply the quadratic formula. And in a problem like this, it would be very important to check your solutions to make sure that what you solve for is reasonable. But this is the approach on how I would attack example 6. So, okay, that'll do it for this video. This is a video on a review of solving exponential equations. So, we did 5 examples, and then I showed you how I would attack a 6th example. Okay, thank you.